Okay, we're going to do a couple of examples on confidence intervals and sample sizes. So, in general, the question is, do you feel the laws covering the sale of firearms should be made more strict? You take a poll of 1,253 people, 464 thought gun control should be more strict. So we're going to create a 95% confidence interval regarding the proportion of people who feel that gun control should be more strict. So let's identify some things here. N is our sample size, 1,253. X is the number of successes or the people who think it should be more strict. The proportion is, sample proportion is 464 over 1,253, which is 0.37 or 37%. But we were going to find a 95% confidence interval by going to StatCrunch. We'll go to proportion, one sample, summary, and we'll plug in our X, the number of successes. We'll plug in our N, the number sampled here, number of observations, and I'm going to click on that, and that gives us our confidence interval. We just calculated the 95% sure that the true population proportion is between 34 and 40%. The margin of error is 3%. That's 37% plus or minus 3%. Okay, let's move on to our next example. Here we have of 1,542 bachelor's degree graduates, recipients, the mean student debt or the average student debt was $30,100. This with a standard deviation of $4,900. And we want to, that's a sample, so our population's student debt is not $30,000. We want to create a 99% confidence interval to find what the average student debt is. So again, let's identify some of the things in our variables in here. We have the N, or the sample size, is 1,542. The mean, the sample mean, is 30,100, and the standard deviation is 4,900. Because it came right after the sample, we know that this is S, not sigma. This is a T interval. Sigma is unknown. We're not going to do a Z interval here. And so be aware of that. If it came before and it said, if the student standard deviation is 4,900, it comes afterwards, it might be a Z interval. So here we go to T-stats. One sample and summary, and I'm going to plug in my sample mean, I'm going to plug in my standard deviation, and I'm going to plug in my sample size, and then I'm going to click on confidence interval. I need to change the confidence interval to 0.99 instead of 0.95, and let's see what we get here. We are 99% confident the true average mean debt is between $29,778 and $30,422. That makes a margin of error of $322. That's not too bad. That's a pretty small margin of error, and that's because we had such a large sample size. Okay, on to the next example of calculating sample sizes. What sample size would you need to estimate the average student debt within $1,000, assuming a standard deviation of 4,900 for a 95% confidence interval? So here we have our formula, and the first thing we need is Z alpha over 2. What we have is a 95% confidence interval. That means we have 2.5% or 0.025 in each tail. So you can go on to StatCrunch or go onto a normal calculator and find area to the right of 0.025, and you'll find that's 1.96. The Z value is 1.96, or a critical value there. So I'm going to plug in 1.96 for my Z value. S is 4,900, and the error that we're willing to assume, or the error that we're willing to take on here, is $1,000, and we obviously can have a smaller sample size than we did in the last example. So if I calculate this, I get 92.2, or approximately, we round up, 93 people would be our sample size for 1,000. Always round up. So next, the White House wants to take a poll on the support of DACA. Without using prior estimates, how many people will they need to poll in order to have a maximum margin of error of 2% for a 99% confidence interval? So here's our formula, n equals 0.25 times z alpha over 2 over this margin of error squared. So we need to find what z alpha over 2 is in this case. You can go ahead and go into StatCrunch to find this margin of error. If we draw a picture of it here, just to see what we need to look up, we have 99% in the middle, 1% over 2 in each tail, that's 0.005 in each tail, and let's see, so let me go ahead and look that up. Let's see, I'm going to go to calculators, normal, to find the z value. I want to put in 0.005, I'm going to put it to the right of our z value, and we get 2.57, actually it's 2.576, but I use 2.575 in this example here. So that is our z alpha over 2. Those are our cutoff values there. So I'm going to put 2.575 on top here, and divide that by 0.02. And what I get is 4,144.14, round up, so 4,145 people.